Okay, this is chapter 4.2, reflections. Essential question: how can you reflect a figure in a coordinate plane? What you will learn in this chapter is how to perform reflections, perform glide reflections, identify lines of symmetry, and solve real-life problems that involve reflection. So let's get to it. Okay, so we're going to start with a core concept: performing reflections. A reflection is a transformation that uses a line like a mirror to reflect a figure. The mirror line is called the line of reflection. A reflection in a line M. Okay, so right here, let me switch to my pen here. Line M is right here. That is our line of reflection. A reflection in line M maps every point P in the plane to a point P prime, so that for each point, one of the following properties is true. If P is not on M, which obviously P's here and M is right here, P is not on M, then M is the perpendicular bisector of the segment that goes from P to its image P prime. In other words, this distance from here to here is perpendicular to our reflection line, and this distance is equal to this distance since this is the midpoint. And that's what the definition of bisector. A bisector cuts something into two congruent pieces, and therefore the point of intersection is the midpoint. Or if P is on M, such as here, then P equals P prime. Obviously, if you're reflecting something that is on the line of reflection, you're still on that line. So this is when the point is on the line. The image is the same point location as the pre-image. On this one, if P is off the line, then the distance perpendicular to here is equal to the distance perpendicular to the image P prime. Okay, so that's it in a nutshell. Okay, here's example 1, reflecting. We want a graph. So here are two graphs. And it says graph triangle ABC with these vertices and its image after the reflection described. So we're going to do two different things. So let's focus on A first. And we want to graph the pre-image, which is the original triangle ABC. So I go over 1, up 3, and put a dot. And I'll call that A. B is 5, 2. And C is over 2, up 1. So there's my A, B, and my C. And in this case, after you draw that, please use a ruler when you're graphing. Don't try to draw squiggly lines. So I'm going to use my ruler this time instead of my line command. And this is how you should graph, because it's going to become, well, it always has been, but it's really important to attend to precision and make sure everything is exact. So here is my segment AB. And then if I just swing this down here, here is AC. And then I need to move my ruler to C and rotate it up to B. And so there is my pre-image triangle ABC. We want to reflect it in the line X equals 3. So I want to draw that line. So I'll make it red. And I'll take my ruler, and X equals 3 is a vertical line at 3, where all X values are 3. No matter what Y is, X is always 3. This is the line X equals 3. Okay, so there's my line of reflection. Now remember, since this is vertical, our segments are going to be horizontal. Okay, so all you have to do now is to find A prime. You ask yourself, well, how far is A from my line of reflection? And that's a distance of 2. So I'm going to go over a distance of 2 and put a dot, and that is A prime. Okay, so now let me just erase those little squiggly lines there. And that's how we find our reflection points. So C, I only had to go over 1. So to get from here to here, I went 1. So you go 1 on the other side, and that would reflect. So picture this paper being folded right on this red line. C would end up there, A would end up there, and B has to go to the other side of the line of reflection. So B went left 2 to get to the line, so left 2 more to get to here, and that would be B prime, and this is C prime. Okay, and then all we have to do now is graph the lines. Create the line segment C prime A prime, create the segment C prime B prime, and then finally segment A prime B prime. So the black triangle is the pre-image, ABC, and the green triangle A prime B prime C prime is the image after it was reflected across x equals 3. Okay, hopefully that makes sense to you. So now we're going to try it again. Now it says B, so in the line M, which is, oh, I didn't name that line either, by the way. This is line N, so then you'd also label the line. I didn't do that. I just said x equals 3. Now we're going to do the line M, y equals 1. So let's do that first. So when you have an equation that says y equals, it is a horizontal line at that number. So y equals 1 is right here. And I'm going to call it y equals 1. And on the other end, I'm going to put the m, because that's the name of it. Okay, so there's our line of reflection. We want to plot triangle ABC again. So that's over 1 up 3 is A. B is 5, 2. 5, 2 is right here. There's B. And C is over 2 up 1, right there. Okay, and so then again, I'm going to plot my lines. Okay, a little tedious, but it's not that bad. And this is C. So there's the triangle ABC. Again, it's identical to this one because it was the same coordinates. Now I want to reflect this across the line y equals 1. So A, I would need to go down 2 to get to y equals 1. So I need to go down 2 more to get to the other side. And there is A prime. C is on the line. So if I go back here, that's this scenario here. So when the point is on the line, it does not move. So this is C, and it is also C prime. So that's going to stay right there. And then B is down 1 to get to the line. So down 1 to get to the other side of the line, the same distance away. So this is B prime. So now I'm going to draw my line segments. AB, or A prime B prime, I mean. A prime C prime, and then finally bring this up to this point here, rotate it, and that is my B prime C prime. So there is the original pre-image triangle ABC, that's black, reflected over the line y equals 1, and the image is the green A prime B prime C prime. Okay, so that is reflecting across horizontal and vertical lines. At this point, you should be able to do problems number 7, 8, and 10. All right, example 2, reflecting in the line y equals x. So now it says to graph line segment FG with these two endpoints and its image after reflecting in the line y equals x. So let me graph the line y equals x first, and I'm going to save time now. I'm not going to use my ruler function. It's quicker to just draw the segment this way, and I will make the line y equals x first. Y equals x is a diagonal where all the y's equal the x's. 0, 0, 1, 1, 2, 2, 3, 3, 4, 4. All the y's equal x. So this is the line y equals x. Okay, so there's my line of reflection. I want to plot the segment FG. I'll do that in black. And it's at F is at -1 up 2. So here is F. And G is over 1 up 2, right here, G. So then I want to draw a segment right there from F to G. So there's my line segment that I want to reflect. I'll reflect that, and I'll use green for my image. Remember, the original is called a pre-image, and the copy is called an image. Okay, so in this case, I need to go diagonal. So I want a perpendicular line to that. So this one's a little bit different. So let me just draw a line that would be perpendicular, and then I'll move it around after. So this line here, I wanted that to be not black. Let me change it. Let's make it purple. That is perpendicular to y equals x. It's the line y equals negative x. So whenever the slope's a negative reciprocal, you get a perpendicular. Okay, so no matter where I move this line, it will always be perpendicular, forming a 90-degree angle here. So when I line that up with F like so, then I can count diagonally, if you will. I went over one whole diagonal square and then another half. So I'm going to go the same distance to get to the other side, same distance away from my line of reflection. So since I went down 1.5 diagonally, I go 1/2 and one more, and my reflection point is right here. Same with G. If I now move my perpendicular line to here, then G is going to end up 1/2 a diagonal away from the line of reflection. So I go 1/2 more, and it's right here. And then I connect the dots, and I get my line segment reflected, which is F prime G prime. So I draw that like that, and then I'll label it. This is G prime, and this is F prime, and I'll get rid of my diagonal, which is perpendicular. Okay, so there it is. G is reflected to G prime, F is reflected to F prime, and that's how you reflect a cross. And we're going to start leading up to rules, but I'm not going to get into that right just yet. Okay, so with this core concept, this is the rules I was talking about on the last page that I didn't mention yet, but here they are. Coordinate rules for reflection. If a point AB is reflected in the x-axis, then its image is the point A, negative B. Okay, I want to explain these more in detail than what they say here. Okay, so here we go. If the reflection line is the x-axis, that is right here. So what they're saying is, if I choose a point, AB, how about 3, 2? This is the point 3, 2. So A is 3, B is 2. Its reflection will still be A3, but B will be -2. So if I go down 2 more, sure enough, if this is A prime is 3, -2. Okay, so that's what they mean. Reflected in the x-axis, the x value stays the same, the y value gets negated. All right, so if you remember these rules, it makes it a lot quicker to answer a problem. Okay, so the next one is, if AB is reflected in the y-axis, then its image is the point -AB. So let me get rid of this. And my line of reflection is going to be the y-axis. So let me move this up to here, like so. Okay, so now this is my reflection line. If AB is reflected in the y-axis, so I have the point 3, 2 still, I'm going to reflect it. So I have to go over 1, 2, 3 to get to the line, 1, 2, 3 to get to the other side. That is A prime. That is the point -3, up 2. So notice AB 3, 2 became -3, 2, or the A gets negated. But from AB, the B stays the same, but the A is negative. Okay, so then if we're going to reflect across the line AB, the point AB across the line y equals x, that is when we have this diagonal here. Let me put this right there and move this over here. So this is our third scenario right here. If AB is reflected, so here's what we're going to do. Remember, you have to go diagonally. So a diagonal movement of 1/2, another diagonal movement of 1/2 would put me here. That is the point right 2 up 3. This is the point 2, comma 3. So notice what happened here. A and B just switch sides. So if A, B is reflected in y equals x, then its image is the point B, comma A. A equals B and B equals A. In other words, x equals y. That's what that means. Okay, so 3, 2 becomes 2, 3. 5, 1 would become 1, 5, and so on and so on. So then the last one is if AB is reflected in the line y equals negative x. Well, y equals negative x is the line diagonal that looks like this, a slope of -1 going through the origin. This is y equals negative x. Let me get rid of this. A is still 3, 2. So I'd have to go diagonal 1, 2 and a half, 1/2, 1, 2. That would put A prime right here, which is the point -2, comma -3. Okay, let me move that name. Oh, I can't. -2, -3 is right there. And notice what happened. 3A, B became -B, comma -A. So 3 got moved to the y position and negated. The 2 got moved to the x position and got negated. So you just flip them and switch them if it is negative x reflection. Okay, so those are the 4 basic rules. And let's take a look. Okay, example 3, reflecting in the y equals negative x. Graph FG from example 2. Okay, so I have to go back to example 2. FG was -1, 2. All right, so I don't know why they did that, but let me copy this. So if here's FG. I don't know why they just couldn't give me the points again, but anyway, there they are. F is -1, 2. So we plot that. -1, 2 is right here. G is 1, 2 right here. Here is F, here is G, and we want to reflect in y equals -x. So let me make that red. And y equals -x goes through the origin with a slope of -1. So there it is. Let me label it y equals -x. Okay, so I'm going to reflect it across. So 1/2, 1/2 is right here. Diagonally 1.5, 1/2, 1. So here's G prime. Here is F prime. And draw a segment from one to the other like so. Okay, so there it is. Now let's take a look at the rule. So -1, comma 2. And what's the rule for -x? If you go back here, -x is A and B get switched and their signs both get changed. So without even looking, I should say F prime 2 goes first and it's negative. -1 goes second and it becomes positive. G prime would be 2 coming first, negative, 1 going last, negative. And let's see if that's true. So -2, 1 is F prime, and that's true. And G prime should be at -2, -1, which is left 2, down 1. And sure enough, there it is. And the only thing I didn't do was draw my segment FG. So let me do that. And we'll be done. So that's what example 3 should look like. Graphing FG from example 2 and its image after reflecting y equals -x. And I checked it with our new rule and it checks. So now you should be able to do problems 13, 14, and 16 on your homework. All right, performing glide reflections. So postulate 4.2, reflection postulate. A reflection is a rigid motion. Keep that in mind. Rigid motion means the size and shape does not change. It just gets moved to a different location. So it says, because a reflection is a rigid motion, and a rigid motion preserves length and angle measures, the following statements are true for the reflection shown. So here we have a line of reflection called M, pre-image triangle DEF, reflected across it and creating the triangle image D prime, E prime, F prime. So as you can see, D is congruent to D prime, so it has one arc. E has two arcs, E prime has two arcs, that means they're congruent. And F has three arcs, and F prime has three arcs, which means they're congruent. The congruent markers for the sides goes the same. DE has one, D prime E prime has one, EF has two, E prime F prime has two, and DF has three, D prime F prime has three. And that's how you determine what's congruent when there's more than one pair of congruent things in a diagram. So all those things I just read to you from the diagram, and because a reflection is a rigid motion, the composition theorem guarantees that any composition of reflections and translations is also a rigid motion. So a glide reflection is a transformation involving a translation followed by a reflection in which every point P is mapped to point P double prime by the following steps. So step one, it says find a translation that maps P to P prime. So this thing got shifted up and to the right. Okay, that's the first step. And then reflected across Q to become P double prime. Do the same with Q. Q got shifted up to Q prime, then reflected across line K and became Q double prime. Okay, so that is a glide reflection. It's a shift and then a reflection. So it says here, study tip, the line of reflection must be parallel to the direction of the translation to be a glide reflection. So my direction has to be the same as my direction of my line being drawn. In other words, the lines have to be parallel to get from P to P prime, Q to Q prime, and line K. These two segments and this line all have to be parallel. Okay, example 4, performing a glide reflection. I apologize for putting a smaller graph in the notes. It's not big enough for this move. But anyhow, I had to change this and go from -10 to 10. Graph triangle ABC at the points 3, 2, which is right here. Actually, I want to use black. Over 3 up 2 is right here. And that is A. B is over 6 up 1, 2, 3, which is here. And C is 7, 1. So here's A, B, and C. Now let me just draw segments to each of those. And so here's segment BC. Here is segment CA. And here is segment AB. So there's triangle ABC as they said to graph. Now we're going to graph its image after a glide reflection. So we're going to translate X comma Y to go to X minus 12 comma Y. So my Y doesn't change, but my X moves left 12. So my A is going to move left 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And I'm going to put A prime right there. B, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. B prime. This is a glide or a translation. C is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. C prime ends up there. So now I'm going to graph those line segments. Here's AB, or A prime, B prime, B prime, C prime, and A prime, C prime. So there is this triangle translated left 12 units. That is the translation or the glide. Now we're going to reflect it in the x-axis. So let me draw that, and I'll draw that line as blue. The x-axis is right here. So we're going to reflect that across this blue line, the x-axis. So to reflect it now, I'll use green. We're going to, remember, go perpendicular. So that'd be down 1 for C prime, down 1 more. And here is C double prime. It's a copy of a copy. So you use 1 more prime marker. B prime goes down 1, 2, 3 to get to the line, down 1, 2, 3 more to get to the other side, the same distance away. And there's B double prime. A goes down 2 to get to the line, down 2 more to get to the other side, same distance away, and there is A double prime. And then I just connect my dots. So here's segment AC. Here's segment C prime, B prime, or double prime. A double prime, C double prime, C double prime, B double prime, and A double prime, B double prime. So here is the glide reflection of triangle ABC in green. Okay, so that's how you do it. Translate and then reflect. Now you should be able to do problems 17, 18, and 20. All right, identifying lines of symmetry. A figure in the plane has line symmetry when the figure can be mapped onto itself by a reflection in a line. The line of reflection is a line of symmetry, such as line M at the left. A figure can have more than one line of symmetry. Okay, well, that's not the line to the left. In this case, I moved it over here. This is a butterfly, and line M is a line of symmetry. So if you cut this butterfly in half or folded it, each portion of the wing, these pieces would land right on the other side. That is a line of symmetry. Okay, so a figure can have more than one line of symmetry. So here's example 5, identifying lines of symmetry. So I'm going to get my segment tool, and that's thick enough, and let's make it red. So it's saying here, how many lines of symmetry does each hexagon have? So if I drew this line of symmetry, what's going on here? I can draw a line of symmetry right there. If I folded that, this vertex would land here, this one would land here, and this would stay where it is because it's on the line. So I could draw this line of symmetry. I could also draw another line of symmetry, and it would be the midpoint, this going this way. So if I move this line of symmetry out of the way, you can see that this vertex would end up here, this vertex over here, this vertex over here. If I folded it over, they would all land on top of each other. And these line segments would also land on top of each other. And the angles would, these two angles are congruent, these two angles are congruent, and so on. So this has two lines of symmetry. Sometimes we can draw diagonal lines of symmetry, but in this situation, that is not possible. So let me try that and show you. If I drew a segment from here to here and I folded that, this would end up over here. It wouldn't hit the same location. This line here reflected across this purple line would go this way. So that is not going to be a line of symmetry. So there are two in this case. All right. So let's try this again. Here's B. Here is a line of symmetry. It can get folded this way. There is a line of symmetry this way as well. And there is a line of symmetry here. So as you can see, if it is, this is called a regular six-sided figure, is called a hexagon. And if they're all equal lengths of sides and equal angle measures, then it's regular. And so there are three lines of symmetry, but I could also, let me change colors because it's getting cluttered. I could also do a line of symmetry here, a line of symmetry cutting it in half here, and a line of symmetry there. So that one has 6 lines of symmetry. Okay, and this last one, you have to ask yourself, where could I draw a line where I could reflect this? And there it is right there. This would get folded over. So this point or vertex would end up here. This one would end up here. This would stay where it is. This would stay where it is. And these lines would all align, if you will. Okay, so that would be right there. There are no other lines of reflection here because of this jutting out further. I can't fold it vertically. So this one had 2, this one had 6 lines of reflection, and this one had 1. So at this point, you should be able to do problem numbers 21, 2, and 24 from your exercises. Okay, solving real life problems. They really had to think about how they're going to do a real life problem for this type of scenario. But here we go. So I'm going to draw a line. Let's make it red. and I'm going to duplicate line M, and then I'll move it down. So there's line M, and let me just shift it down here and label it M. So here's line M. So this is the parking spaces in front of a strip of stores. So the bookstore says you're going to buy books. So there's two people in the car. One is going to go to the bookstore, and your friend's going to buy CDs at the music store. Okay, so this is obsolete as well because, well, I guess you still can buy CDs if you're a collector, but most of us just download off the internet. Where should you park to minimize the distance you both will walk? And that goes for books too, by the way. So you could just park on the couch at home and download something off of Apple Tunes, and then you could use Kindle to get your books. But anyhow, there's a real life scenario. Where should you park to minimize the distance you both walk if you want hard copies of a book and CD? Okay, so this is line M. That is the line at the ends of all the parking spaces. Point B is right here. So the first thing you want to do is reflect B over line M. So I'm going to put B in about the same place down here. So this is B. So here's B. You want to reflect it across to here and call that B prime. Okay, so that's the first thing you want to do. Now you want to draw, and A is right here, by the way. Here's the music store. So A is the music store, B is the bookstore door, and you park somewhere in between them. And so reflecting B across here to B prime, then we can draw a line segment from A to B prime, which is right here. So that is a line segment AB prime. And the shortest distance between 2 points is a straight line. So if I do this, then I notice that right here, let me change it to black, right here is where my line segment intersects. So that means that this distance from here to here is equal to this distance here to here. And if I drew the same segment from B to here, and let me change that color, purple, and I'm going to label the point where these all come together as C. So since I reflected B across line M to B prime and found this distance here, this distance B prime C is equal to BC because it's a reflection of that line segment over M. And the shortest distance from A to B prime is a straight line. C is the midpoint, so that would make B prime C equal to AC. And if B prime C equals AC and B prime C equals BC, then by the transitive property, BC equals AC. So you should park at C, which would be right in the middle here. Okay, so that's where reflections could be used in a real world scenario. But the length of time it took to explain this, you could have walked in, bought a book, and gotten back to the car. But just saying. So now here you should be able to do problem number 27 on your exercise. Okay, this brings us to the end of chapter 4.2. Here are the exercises that you should have been doing along with the video, but here's the list of all of them. Have a great day.